generative AI, it's just everywhere, right? It feels like it's changing everything about how we create, how we work, even how we think. But have you ever stopped to wonder, how does it actually work? What's going on under the hood? Well, it turns out it's not just magic. There's a really fascinating system behind it all. So today, let's dive in. We're going to peel back the layers and go from the very atoms of AI all the way up to the incredible applications we're all using. I mean, the explosion is real. The whole landscape is just massive. You've got large language models, or LLMs, that can write entire essays for you. You have AI that can synthesize images, video, even music out of thin air. We've got these incredible coding assistants helping programmers write better code faster. And that's before we even get into brand new fields like prompt engineering or these super advanced autonomous LLM agents. It's a lot, I know. So to really get a grip on all this, we've got to go back to basics. We have to start at the very beginning.
Okay, so let's start with part one, from text to tokens. We're talking about the absolute atoms of AI language here. Think of it like this. We're zooming all the way in, past all those flashy applications, right down to the most fundamental piece of the puzzle. So here's the big question. How does an AI actually read? You type a sentence into an LLM and it gives you an answer. But what happens in between? It's definitely not reading words and letters like you and I are. For an AI, language isn't about meaning, it's about math. So the very first thing it has to do is chop our human language up into something that a computer can actually work with. And that something is called a token. This is the key. AI researcher Andrej Karpathy had this perfect analogy for it. He called tokens the atoms of large language models. And it's so true. They're these tiny, fundamental units that everything else is built on. Every single thing an LLM does, whether it's reading your question or writing a poem, it's all just manipulating these tokens. So, how does a model come up with these tokens? Well, most of them use this really clever algorithm called byte pair encoding. It sounds complicated, but the idea is actually pretty simple. It starts by breaking down text into raw numbers, or bytes. Then it just looks for the most common pair of numbers side by side and says, okay, you two are always together, so let's merge you into a brand new single token. And then it just does that again and again and again. Find a pair, merge it, find a pair, merge it, over and over, building up a whole vocabulary of these common chunks of text from scratch.
And this is where you start to see some of the weird quirks of tokenization. Because this whole process is based on statistical patterns it found in its training data, you get some non-intuitive results. For example, the tokenizer might have seen the number 127 so many times that it decided to make it one single token. But maybe 6077 wasn't as common, so it sees it as two separate tokens, a 6 and a 77. And this is so important to understand. The model doesn't see the number 677. It literally sees two different puzzle pieces that it has to figure out what to do with.
All right, next up, prompting, which is basically a whole new way of programming. Now that we know how an AI reads our world in tokens, the next logical step is how do we talk to it effectively? And that, my friends, is the art and science of prompting.
And what's so cool about this is that, you don't need to be a hardcore coder to do it. Anyone can write a prompt. But, and this is a big but, there's a huge difference between just typing a question and crafting a really effective prompt. It's a skill, and when you get good at it, you can unlock incredible new abilities from these models.
Okay, let's look at a perfect example. Here's a little logic puzzle. When I was 3 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner? If you just throw that at an LLM, it'll often just mess it up. Like here, it came back with 63. It just kind of latched onto the numbers 20 and 3 and did some bad math. It's taking a lazy shortcut instead of actually thinking.
But now, watch this. We ask the exact same question, but we add 5 magic words at the end. Let's think step by step. This is a game-changing technique called chain of thought prompting. And just by adding that little instruction, you force the model to slow down and show its work. And look, it reasons it out perfectly. When I was 3, my partner was 9. The age difference is 6 years. So now that I'm 20, my partner is 20 plus 6, 26 years old. Bam. Correct answer. All because we guided its thinking process.
So we've seen how good prompting can guide a model's internal reasoning. But what's the next big step? Well, it's connecting that powerful brain to the outside world. And that brings us to our next section, AI agents. This is where we go beyond just text and give AI, hands and eyes to actually do things.
And the difference between a model and an agent is absolutely fundamental. A standard model, its knowledge is frozen in time. It only knows what it learned during its training. But an agent? An agent can connect to external tools, it can get live, up-to-the-minute information. A model just gives you a single answer to a single question. An agent can create a whole plan and carry out a sequence of tasks to get something done.
So here's the simplest way to think about it. An AI agent uses a large language model as its brain. It's the core reasoning engine. But the agent's job isn't just to chat with you. Its job is to act, to plan and execute tasks out in the digital world by using a whole toolkit of external programs. And when we say tools, we mean, well, literally anything. You can give an agent access to Google Search so it can look things up. You can give it a code interpreter to run programs, or a calculator to do perfect math. You could even hook it up to APIs to book flights, access databases, or manage your calendar. These tools are what transform a model from a thinker into a doer. Okay, so how does an agent actually think and decide what to do? A really popular framework for this is called REACT, and it's short for Reason and Act. It's basically a simple loop that just keeps repeating. First, the model has a thought. It thinks, what do I need to figure out next? Then, based on that thought, it chooses an action, like, I'm going to use the search tool to look up this term. After it takes the action, it gets an observation back. That's the result from the tool. And with that new piece of information, it goes right back to the beginning to form its next thought. It just keeps running through that loop. Thought, action, observation, until it finally has enough information to give you the final answer. Okay, wow. We have gone on quite a journey, haven't we? We started with the tiny atoms of AI language, tokens, and we've built all the way up to these complex agents that can actually take action in the world. So for our final section, let's zoom back out and ask the most important question. What does all of this actually mean for you? So if you remember anything from this, let it be these key ideas. First, AI reads our world by breaking it down into little pieces called tokens. Second, prompting is a real skill. It's how we guide the AI's thinking process. And third, AI agents are the next big frontier because they combine that powerful thinking with the ability to act using tools. This whole evolution is transforming AI from just a fancy text generator into a genuine partner that can help us solve real problems. And that really leaves us with the biggest, most exciting question of all, doesn't it? We now have technology that can reason, plan, and act in our digital world. The capability is here. So the real question we all have to think about now is, what amazing, difficult, and important problems are we going to ask it to solve next?